Photobiostimulation is the compound word of photo, meaning by light, and biostimulation, a practice in which intracellular processes can be stimulated by outside factors to increase efficiency and rapidity of healing or growth. Also known as LLLT, or low-level laser therapy, HPLT, high-power laser therapy, and PBM, photobiomodulation. But for sake of repetitiveness, let's call it PBS. This application is used to reduce inflammation and chronic pain and to improve soft tissue and wound healing. Let us see how it works. At its most basic, PBS uses spot treatment via lasers, or light amplification by stimulated emission of radiation targeting the affected area. Wavelengths between 600 and 950 nanometers, just short of the infrared range, are used depending on how deep the targeted tissue resides. Longer wavelengths are required to penetrate deeper through the epidermis and the dermis. With the laser focused on the skin, the light can either be reflected, absorbed, scattered, or transmitted deeper through the tissue. This happens at every plane of incidence between the light and a different medium. As an example, consider light passing from extracellular fluid to the intracellular medium via the lipid bilayer membranes, where it can be reflected at every stage. Light itself, via quantum mechanical theory, consists of photons, which are regarded as forms of electromagnetic radiation and which carry energy via their momentum. This photonic energy is the essence of PBS. Most important in the discussion of PBS is the absorption of this light energy. Once the light is transmitted into the targeted tissue, chromophores are required to absorb the photonic energy that it carries. At a cellular level, mitochondrial photosensitive chromophores are the main performers enabling PBS. The photonic energy inspires an oxidation-reduction reaction when incident light stimulates electron displacement. These electron transfer reactions are instrumental to the increased production of ATP, the main energy carrier and the base of the majority of cellular processes. To recap, we now understand that incident energy-carrying photons from the laser are transmitted or scattered to the cellular scale and are absorbed by mitochondrial chromophores, which incite ATP production. As mentioned at the start, PBS is used to reduce inflammation, reduce chronic pain, and accelerate wound healing. Let us break it down. For its anti-inflammatory and pain benefits, PBS acts more as an inhibitor than as a helper. Neurons, the cells responsible for transmitting sensation to the brain, are the main area in which PBS's anti-inflammatory benefits are to be observed. The enhanced ATP production is detrimental to neuronic function, as the surplus in ATP often destabilizes these cells. The stimulated overflow of ATP in the cell generates an excess of mitochondrial movement throughout the cell's cytoskeletal network, resulting in a cellular blockage and inhibiting the transport of information from the neuron. In turn, the lack of neuronic information has been shown to reduce inflammation and pain within a few minutes. For its wound healing potential, PBS as a procedure acts as a catalyst and a facilitator to many processes responsible for cellular regeneration. To understand how PBS aids in wound healing, we first need to understand how wounds heal. We will mainly be dealing with keratinocytes, which are of utmost importance to the epidermis and which regulate the barrier, and fibroblasts, which generate proteins and molecules that are instrumental to the process of tissue repair. Most importantly, keratinocytes and fibroblasts operate in a mutualistic setting. Fibroblasts produce growth-aiding proteins such as collagen and fibronectin, which in turn enhance keratinocyte proliferation cyclically. This, of course, speeds up the healing process. The supplementary ATP produced by PBS is used by fibroblasts in their production of collagen and other proteins. The contribution of PBS to keratinocyte-fibroblast interaction cannot be understated and is a key accelerator to wound healing. To conclude, the process of photobiostimulation, whether via low or high-level lasers, has proven benefits that combat pain and inflammation and that vitalize wound healing through its stimulation of ATP production.